All right, and we're live, so we can actually continue now. Okay.
Does everybody have SPSS open?
Yes.
Yes, I do.
Let me start that now, and by the time that we're done with everything, it'll be open.
Yeah.
Okay, so we're going to go over part 2 of lesson 14, right?
Yeah. Hold on. This
Okay.
is acting weird. Oh, I can tell my SPSS is open. Everything is going extremely slow.
Yeah. Okay, should we start number 1? What is the research question?
Yeah.
That's different between categories of writers.
Right. And I wrote down novelist, poet, and nonfiction. And then what's the? Can anybody state the null and the alternative hypothesis?
So I believe the null is all the means are equal, right?
Yeah.
Right.
And then so would the next one just the alternative would just be one or more of the means differ?
Yep.
Yeah.
Okay.
From the others, right?
Okay.
And then collect the data. We're not sure how they collected the data. We just have the data.
Yeah.
I just put that they collected the names of authors because they were all dead, so they would just have to go and find names of authors and find their death dates. So they collected the names of authors and selected categories of writers and recorded their age of death. I have no idea if that's what they did, but this is the answer she said.
And you can't really. Can you describe the data collection procedures? Because we don't know what they did. I just left that blank.
Well, so you well, I watched like the little videos on the homework, and that he just says we can't say how they collect it because since they didn't say it in that paragraph, we just have to say we don't know exactly. You can assume all you want, but because it doesn't say how they did it.
Yeah, there's no facts. So
yeah. Well, and if you look at the answer key, it does say we only know that they looked at the ages of the deaths for female writers in North America, but we don't know how they collected it. Obviously, we can put 2 and 2 together, but because it doesn't say it in the problem, we can't really assume that.
Okay. All right, in a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. I just wrote in my graph and that the QQ plots all look normal.
Yeah, I basically have the same thing.
Because I don't know how to... well, I guess I could figure it out by copy and paste it and stuff, but I print mine off every week, so...
I do mine
all right.
A little tipsy.
Okay, for what type of hypothesis test is appropriate?
ANOVA.
Yeah, since we're
dealing with more than 2 means.
Yes, more than 2 means. What are the requirements for this test?
The data is normally distributed, and the variance, the high end and the low end is not greater than 4 times. I don't know how to say that.
I like the largest variance is not more than 4 times the smallest variance.
Yeah.
Yeah, that's what makes sense to me. It's hard to. English, I think, is a very limited language, and so we're trying to describe this. It's hard to use the words that we have to make sense of what we're trying to say.
Yeah, I know.
Yes?
I know.
Okay. Let's see. Are the requirements met for this test? Is normally distributed in the QQ plots or normal? So yes, they are. And compute the test statistic for F equals 6.563. And E state the degrees of freedom 2 and 120. And compute the p-value. P-value is 0.002. And the alpha level is 0.05. So G, we reject the null because p-value is less than alpha. H, we have sufficient evidence to, I can't read my writing. We have sufficient evidence at least one of the mean ages is different. And take action, I wrote Poets died earlier. I thought maybe it was genetic. I don't know, we don't have a lot of, well, like if you think about it, stereotypically speaking, poets have emotional, mental handicaps, disabilities, issues, whatever you want to say. So
I want to
maybe.
I kind of was thinking along the same lines as well. Just put pet poets or more gloomy. Maybe find ways to
Like seek counseling? I don't know.
Sometimes a lot of them get stuck writing really gloomy things over and over. So.
Right, and like the F, H, and G are all like I put it all in F, and then like we had to put it in G and then H. So I'm used to that being all one question, not three separate ones. So.
Okay, are we ready?
Let's do it.
Let's get Mark on his way. We're your cheerleaders, Mark.
Thanks, guys.
Hey, now what did you guys say about using, like you hit, what did you do to look at different screens on your computer, Shancy, last week? You hit Control?
No, Alt-Tab.
Alt-Tab, that's what it was, Alt-Tab. Write that down.
All right, I'm starting. Oh, whoa. Do I need to pull anything up first? No.
The best interpreter. Okay.
Shancy, you're really echoey. Maybe it's just me, but.
She sounds fine to me, yeah.
Oh, she does? Okay. Maybe it's just me then.
Remember when we were talking to Brother Balls the other day and it was your headphone? You have your headphones. I'm not even looking at you. Do you have your headphones on?
I do.
Huh. This question, number 2, is like similar to one I missed on the homework one. It was the one I missed.
I'm still working on getting there. My computer's going really slow.
Okay.
Okay, I'm there. Is everybody else there?
Yeah.
Mm-hmm.
Number 3 is true.
Huh?
What number are you guys on 4 now?
Yeah, I'm on 4.
Okay.
Oh, I missed. I didn't hear anyone say anything about number 2 or 3.
Well, 2 is true.
There, 1, 2, and 3 are true.
Oh crap! You know what? I'm in the wrong one. I'm in 15th. Save for later.
Oh my gosh, my computer. I think the test froze. Probably because SPSS. Yeah, I can't do anything at the moment.
Oh no.
Yeah.
4.
Yeah, it won't even let me scroll down.
Number 4 is
B.
well, it's B.
Or is it
Well,
D?
let you.
But it's also C, isn't it?
Yeah. So it's actually E, B, and C.
Hold on.
Okay, it's C on 5.
Whoa, slow down, guys.
So sorry.
I'm trying to get I had to open it up in another one because it wasn't working. Okay. So 4 we said.
was B and C.
B and C. Okay.
5
Got it.
is construct a QQ plot.
I get that one.
Number 6, I haven't read yet.
It's B.
It's B. Yeah, the largest variance is less than 4 times the smallest variance.
Yeah.
That's what I said. Huh.
4. Two independent. No. 1 to 2, 1 to 3, 1 to 4.
This is a weird question.
Holy cow. Okay.
5 to 6.
Okay, so 1 to 1, or I mean 1 to 2, 1 to 3, 1 to 4, 2 to 1, 2 to 3, 2 to 4. How do you get 6?
I don't think you would do 2 to 1 because you already have 1 to 2, which is the same pair.
That's
So
right.
1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4, 3 to 4.
Yeah, it's 6.
Okay, yep.
What'd you say back? 1 to 2, 1 to 3, 1 to 4, 2 to 2, 2 to 3, 2 to 4?
No, 2 to 3, 2 to 4. I didn't put 2 to 2.
Oh,
All right, we're gonna have to open up the soccer shoes data. Okay.
Oh, great.
Oh my gosh, come on. Oh, guys, this is acting so stupid. It shut me down out of my SPSS. Oh dear. Love this.
Ask Daddy, okay, honey? Thank you. Is he inside? Can you find Daddy?
No.
Okay, I will text Daddy, okay? Just a minute, okay, babe?
All right, so the data file we're looking up.
What is it called? Soccer
shoes, right?
I don't know.
Yeah, I believe it's soccer shoes.
Soccer shoes.
Okay.
We have this open. What do they want?
okay.
The p-value is 0.0.
9. Remove the socks data. Here's the p-value.
Remove the socks data. What is the p-value?
So we need to go do back to our thing and take out the sock.
How do you do that?
Go back to your original thing and delete it.
Oh.
And then do another one-way ANOVA.
What?
So go back. You know where it comes up with the columns with footwear and accuracy and you recode and you can see your other 1, 2, 3. Before you get all the data, it's the screen that opens up very first. You scroll down, and just like you do in Excel, you could just highlight everything that was socks and delete it, and then just run another one-way ANOVA test.
Okay, I got mine.
I
Well,
want us to run the test and then go back and delete the socks, or just delete the socks in the first place?
can you do a screen share? And my computer's acting out of control.
Yeah. Let's see. Okay, so can you see it?
Yes.
So here's all your data. Let's come down here. I've already run my other one-way ANOVA just in case we need it later. But then I came in here and I highlight it, I hit delete. Now I'm going to come up. And
Which ones were you deleting?
socks.
Socks.
Oh, okay.
So then I just come up here and I do my descriptive, no, compare means, and then do my one-way ANOVA. And I have my kicking accuracy as the dependent. I've got my footwear recode. On my options, I've got descriptive and the means plot. And so then when that's done, let me share my other screen. Okay, so when that's done, this is what I came up with. Mark, did you get, wait, where am I? 0.309.
I did, but I'm wondering if maybe that's not how we do it, because the next question is saying that all 6 samples are supposed to be included.
Great job, honey. Good job. Okay. So we're supposed to run that regular and then take the socks out and then run it again and then
Well, I ran, yeah.
for the next question? Is that
Well, I ran it the regular way, and then I went back and ran it again after I took the socks out. So it said load all 6 samples and do an ANOVA, and observe that the p-value is 0.0809, which we did, and it rounded it to 0.081. And then it says remove the sock data, and what's the p-value on that? So I went back and removed it. So I've still got the data from both tests. So, 0.309.
hold on a second.
Yeah.
Value. Okay, so always goes up and it's removed. Mark, did you put true on 9?
One second.
Janet, I need you to come in here, please, right now. Why are you not answering my text or my phone? Love you. Bye.
You're in trouble, but I love you.
I didn't put anything. I'm going to try the experiment again. I think that it's false.
Oh, because look at yeah.
If you,
Sorry,
I took out E this last time, and I got a p-value of 0.050. I'm going to try it again with a different one.
Number 10 wants us to go through and do an ANOVA test on every single option and write down the highest p-value we see.
Okay.
0.309. So,
It's easier if I didn't have to keep switching all these screens.
I know, right?
Oh, from the schools back to mine.
Alt tab.
Is number 9 false, you guys, right?
Yeah, I think so.
What did you guys get for 8?
I got 0.309.
Me too.
0.039?
309.
309?
Mm-hmm.
And then-
0.309, right?
0.309.
Okay, I had it typed in right. Round to 3 decimal places.
My SPS is not working at all.
No, mine keeps freezing. And it keeps freezing.
Mine too.
Anything I have on the same screen is that it's freezing it up.
Okay, so what I'm doing right now is the same thing I did when I took off the socks, but I'm one at a time taking everything off.
Yeah, so you're doing the A, then the B, then the C, going through all of them.
Uh-huh.
Okay. I'm just kind of writing down.
Jancy, can you screen share with us, please, so I can
Oh, yeah.
see?
Yes.
Thanks.
Uh-huh. Oh, I'm sharing the wrong screen. Sorry. Let's do this one. Okay. Okay, so I just ran a test on that, and then I hit undo. My C comes back. I'm going to come up and I'm going to do the B.
Or can you hit reset too? Does that work as well? Or not?
Can I do what?
Can you hit reset?
Maybe. I haven't tried that. Do analyze, compare, ANOVA. Okay. And then undo. And then copy. Okay, so I've got all the ANOVA tests run, and I'll share that screen with you now
Okay.
on the results. There. Okay. So now it wants us, here's the main one, the first one we ran, where the, wait, this one. Oh, that's mineral, that's for the other. I forgot that it kept it on there. Okay, here's the soccer shoes. Okay, so here's the first one that it did. All the way to the bottom. Okay, so right here on question number
10?
back on number 8, it says observe that the p-value is 0.0809 or whatever. And right here on the significance, they rounded it, it's 0.081. That was the first one I ran. And then it said take out the socks. And so I did that. And here's the p-value right here. It went to 0.309. So that's where we got number 8. And then it wants to know what the highest p-value is that we see after that. So there's 0.050 and 0.031. Mark, you're probably already done, huh?
I just went through and did it by hand. Like, I just copied and deleted each one and ran a quick test. I didn't do it with QQ plots and everything.
Oh, I didn't change any of my settings, so I just did it quickly. 0.060 Okay, so the ones that I got marked, did you write them all down? 0.309, 0.050, 0.031, 0.448, 0.052, 0.060.
I didn't get .060 for the last one. I got .098, but let me double check it. All the other ones I got were the same.
Okay. Even with those being different, they want to know what the biggest one was, which is the 0.448. Right?
Right.
And the 3 decimals, so 0.448. Ladies, did you get that? Could you see that when I was scrolling through?
Yes.
Mm-hmm.
And thank you for doing that.
No problem.
Sometimes it gets
Yeah, I
really
got
frustrating.
.060 that time.
You got what?
I got the same answers, yeah.
Okay.
I did it wrong the first time.
Okay, so when all 6 samples are used, what is the minimum or smallest variance? So we need to go back up to that first one we ran, right?
The
I got
.031.
.031.
Yeah.
Oh, is that what it's asking? Okay. Yes. 0.031.
Wait a second. I don't know
That's,
if that's the right answer.
I don't think so either, because
It's talking about variances, not p-values.
right. Oh, this is silly. Where do we see the variance? The variance, isn't that the deviation? No. Mark,
Okay.
Yeah.
where do we see the variation?
You what?
Where is the variation? Where do we see that?
I have no idea. I'm looking
Because
for it now.
the variance from the mean would be more like the standard deviation, like deviated from the mean.
You
So
what?
would we be looking at the standard deviation column? Because it tells us how far from the mean they have varied or deviated. I have no idea, I'm guessing. Are you laughing at me?
Okay, look, I'm going to read this to you. It's from the notes. It says, you can find the variances for each group by looking at the same output that generated the QQ plot. Look for the descriptive table.
Okay.
Oh yeah, it's in the big table. We'll say variance on it. Okay, so number 10 is 0.448.
Yes.
Number 11 is 0.031. And number 12 is 0.448.
We don't know 11 or 12 yet.
Okay.
Maybe she does.
Oh, because that's what we're looking at right now. So the variance.
Descriptives.
So Shancy, can you screen share with us?
Oh, I thought I was.
Oh, well, I see your mouse moving and it going up and down. I think it is.
It's not sharing that screen?
No,
No,
it's not. No, it
No.
is. No, it's not.
You just gotta talk the whole time.
You just gotta keep
Or
talking, Shancy.
If you guys just click on her box, a lot of times it will just keep hers up. That's what mine does. Do you see what I'm saying?
Yeah, can you scroll up or down? We gotta see where all the tables all come out in the beginning, probably.
Well, look at, because I'm going to read it to you again. You can find the variances for each group by looking at the same output that generated the QQ plot. Look for the descriptives table.
Keep
So it will
scrolling
say
down.
descriptives above it.
It should be one of the first things that you run. Okay, right. see variance right there, 40.724.
Here.
It's 5% trimmed mean, median variance.
Oh, right there.
Do you see that?
40.724.
Correct.
Scroll up just a tad bit more.
Oh, there it is. Yep, I see it. Okay.
Okay, and then for every one, it's going to tell you a variance for SACS, E, whatever. That's what it's
31.011. Okay. And
Yeah.
then 53.158.
Right.
For the smallest?
No, I'm just writing all of them down right now.
31.11, and then 53.158, and then 27.208, 29.484, and 27.358. Okay, so the smallest is
27.208,
Yeah.
and the largest is 53.158.
Correct.
0.158, right?
Yeah, 53.158.
Okay. The test for equal variances is satisfied for these data.
Go back to your QQ plots.
Okay. They look fairly normal. There's one or two.
Oh,
Yeah.
that's
Yeah, we're
the,
not supposed to look at the detrended ones, so the normal ones. But they all look pretty good, or good enough to be considered normal, right?
I think so.
I think so, yeah.
Okay, so
The test for equal variances is satisfied because the highest is not more than 4 times larger than the smallest.
right. Okay, true. Construct a QQ plot for each of the 6 samples. Each of the samples are all approximate. Okay, so that's true. We just looked at them. Right?
Correct. I would say that they were normal.
Okay, and the test statistic for ANOVA hypothesis is the p-value to the area to the right or the left of the F. Okay. Well,
I know this type of test is right skewed.
That's right.
Well,
no,
But I don't know
it's
if that's anything to do with the p-value.
look at my screen right here that I'm sharing. Can you see where my mouse is going now? It's to the left of the p-value. The F is to the left of the p-value.
Okay.
yeah, but it's asking the p-value is to the right or left of the F. The p-value is to the right.
Oh, yes, the p-value is to the right. Okay.
See you later.
100%.
Oh, we didn't even have to do a countdown. Awesome.
I'm making sure I have them all filled in. Sweet. All right, are we done with the... We don't need to discuss anything else on the recording, do we?
No, I'll end it, and then that way if we have anything else we want to talk about, we can, and then that way Mark can
Go.
get on to what else he's got to do.